Understanding Dynamic Simulation, a guide for English language learners. Hello, everyone. Today, we're diving into a fascinating topic that combines technology and real-world applications: dynamic simulation. If you've ever wondered how scientists, engineers, or even game developers predict the behavior of complex systems, you're in the right place. We'll break down what dynamic simulation is and why it's so crucial in various fields. So, let's get started and unlock the secrets of dynamic simulations together. Dynamic simulation refers to the use of computer models to predict how complex systems behave over time. Unlike static models, which provide a snapshot of a system at a specific moment, dynamic simulations allow us to see how systems evolve. They incorporate variables that change with time, such as speed, temperature, or population growth, providing a realistic and interactive depiction of how systems operate under different conditions. At the heart of dynamic simulation is the creation of a virtual model of the system being studied. This model is built based on mathematical equations that describe the behavior of each component of the system. By inputting different values and conditions into the model, we can simulate various scenarios and observe the outcomes. This process involves sophisticated software tools that can handle complex calculations and generate visual representations of the data. Dynamic simulation plays a pivotal role in many areas, including engineering, environmental science, medicine, and entertainment. It helps engineers design safer vehicles, enables environmentalists to predict the effects of climate change, assists medical professionals in understanding the human body, and allows game developers to create more realistic environments. By providing a way to test scenarios virtually, dynamic simulation saves time, reduces costs, and minimizes risks associated with real-world testing. To illustrate how dynamic simulation is used, let's look at a few examples. Weather forecasting. Meteorologists use dynamic simulation to predict weather patterns, including storms and temperature changes. Vehicle design. Automakers simulate crash tests to improve safety features without having to destroy actual vehicles. Epidemic modeling. Health experts simulate the spread of diseases to understand potential outbreaks and devise strategies to combat them. Dynamic simulation is a powerful tool that helps us understand and predict the behavior of complex systems in a safe, cost-effective manner. It bridges the gap between theoretical knowledge and practical application, allowing for innovation and improvement across various fields. We hope this video has shed some light on the fascinating world of dynamic simulation and its significance. Thank you for watching. And don't forget to explore more about this intriguing topic on your own. Remember, learning is a journey, and every step forward opens new doors of understanding and possibilities. Keep curious, and see you in our next video.